Good morning, pilot teachers and students. Good morning, class. Okay, thank you. You may sit down. All right, our topic for today will be also on electricity, and the subtopic would be charge and current. Enra, can you tell us what an electric current is? What is electric current?
An electric current is the flow of electrons through a second.
Okay, good. So the electric current is simply the flow of electrons. Now in the last lesson we were looking at the electron and basically the current. Okay, what happens? So you know that an ampere is a rate at which one of the charges will have to flow past a point in an electrical circuit in a second. Okay, that is what we went through in our last lesson. So quickly go through now. That is electricity, and the topic, which is a subtopic, that is charge and current. Okay, what is electric current? That was a question, and our answer from NR was, okay, an electric current is simply the flow of electrons from the positive to the negative in an electrical circuit. Right. Yesterday, when we were going through looking at the charges or the electrons, they will flow in the opposite direction. Okay, the charges, for example, they will be moving from the negative towards the positive, but the current will have to move from the positive towards the negative. Right, I'd like you to go through quickly, have the definition down quickly. Okay, pilot students, you can also do that, quickly go through and copy the definition. Right, here comes the next information on the topic. All right, if you were trying to measure the current, the charge must flow through an ammeter, and this is done by connecting the ammeter in series circuit. Okay, now there is a reason for connecting that ammeter in series circuit. Right, as we go through measuring current, you'll be able to find out why an ammeter must be always connected in series. Okay, here comes the next information. Okay, looking at that, the current is given by the symbol which is I, or letter I, that is capital letter I, and it is measured in amperes or A, and the current of 1 ampere means that the column of charges pass a point in a second in 1 second. Okay, I'll quickly go through. All right, for our correction, I will quickly go through it and make the correction. This one should be coulomb second and -1. Okay, it should be coulomb second -1 or coulomb per second. All right, that is for this. Okay, there is an error with this. Or you can have it as 1 coulomb equals to 1 AS. So not -1. This -1 should be removed. Okay. All right, you follow this. All right, you will find that the current equals to, because the ammeter has to measure that current, this current equals to charge over the time. All right, the unit for current will be amps, and it is given by, it is A. That is why A equals to the unit of charge, which is coulomb. So A equals to C over time. Okay, that is S, which is the unit for time. Therefore, we have this equation as if 1 amp has to pass a point, that means 1 coulomb of charge has passed a point in that circuit in 1 second. If the ammeter gives you 1 amp, right? It can be the other way around. If it is 1 coulomb, then you know that it is 1 amp second. Okay, 1 amp second. So 1 coulomb equals to 1 amp second, or it can be 1 amp equals to 1 coulomb per second. All right, you're finished with that. I'll give you the next information, and that is All right, you find that the size of the current will depend on the amount of charge that is passing any point in a circuit every second. So where the I stands for electric current and T for time, and then you have Q, which is for the charge. Okay, probably some of you may be aware of this. You know how to find the subject of that formula. But anyway, we have to go through. This is the same thing as which was explained to you earlier. Q or I equals to Q over time. And when you are having finding that Q, right? Q equals to I times T, right? That is similar to these equations up here. Has everyone finished copying their notes? Yes? Okay, good. You are now finished. I will give you the next information. Right, this one is basically on how you can connect the ammeters. Now it says it must be connected in. Okay, so the circuit so that the current can passes through these ammeters. Now when you are connecting this, you will find that the positive battery terminal should be connected to the positive or the red terminal of the ammeter. Alright, this is done, the ammeter will be, or if this is not done, the ammeter will be damaged. So when you are connecting the positive to positive, okay, that is how you should do that. Right here is the next slide, and that is the questions. The pilot students, you can also go through and copy the questions. There are 3 questions to this topic. After that, probably your teacher will have to come back to you for the answers. Alright, first one is basically on calculation, and another question which is similar question on calculation, and you have the last question which is simply explanation. So quickly copy question number 1. I'll show you question number 2 and 3 as well. All right, question number 1 is find the size of the current flowing through the wire when 0.8 columns of charge passes a point in a circuit. Should be circuit in 1 second. Right, here is question number 2. All right, you find it as self starter of a motor car uses current of 20 amps for 10 seconds. What quantity of electricity flows through the starter? That is question number 2. Okay, now to our last question. Okay, what is electric current and what conditions are necessary for the current to flow in the circuit. Right, if you have finished copying the questions, quickly go through and then show you working out the calculations for the first two questions. And the last one is basically explanation. You can also discuss this question among yourself and then give you answers. So the pilot teacher, you can also ask the students to go through question number 3 and then come up with the explanation for that question. Question number 2, question number 1. Okay, do question number 2. Show your calculation on the board. Question 2. Okay, question 3. Okay, raise your hands up if you have finished question number 1 and 2. Okay. We will now go through the corrections to the exercises, question number 1 and 2. So, pilot students, you may observe carefully as the model students will be showing, let's say, giving you the answers to other questions to our topic. Right, the first question, Charlton, you do question number 1. Question 2 will be, okay, failing, and third question will be John. Okay, so you, come up, write your answers on the board, and then show your explanation.
Given the formula current equals charge over time, the question has to find the current. So the charge given was 0.8, and the time in seconds was 1 second. So therefore the current is equals to 0.8 amps. Thank you.
Very good. Right, that is the answer to question number 1.
The question asks to find charge. So given that the current is 20 and the time is 10, I multiply 20 times 10 to give my current. So the current is 200 C.
Okay, the answer is quite correct. Looking at this, it's asking about the quantity of the electricity that flows through. So that is asking about the charge that is going through. So that means you have I equals to Q over time, and this time you are asked to find Q, since you were given the current and also the time. So 20 times 10 will give you 200 coulombs. Right. Now to the final question, what is the conditions necessary for current to pass through? Okay, what are some of the, maybe you can give us one or two conditions which are necessary for that.
Question 3. What is electric current? It's a flow of electrons, as we learned earlier. Flows electrons from the positive to the negative terminal. And conditions are, firstly, you must have a source. Secondly, good conductors of electricity. Thirdly, it must be closed, meaning there must be no breakage in the circuit.
Okay, he has given us three conditions which are necessary for the electrons or the current to flow through the circuit. The first one, there must be a source of that electricity or current. Without a source, there won't be any current flowing in the circuit. Right, that is number one. Number two is there must be a conductor. Now, conductors, as you have seen, they have different types of, or two types of conductors. One is a poor conductor, and you have a good conductor. So in order for electricity to pass through, there must be a very good conductor of this current or electricity. And the last one is that if you are connecting a circuit, the circuit must not be open. It must be complete in order to have the electrons flowing from one point to the next, or let's say current flowing through that. So those are some of the conditions which are necessary for current to pass in a circuit. All right, looking at our answers to the questions, basically you'll find that for question number one, this is not 0.4, but it is 0.8 amps. And the second one, which is 200 coulombs of charge. All right, quickly to summarize what we went through today, and that is on charge and also the current. We know that especially when an ammeter gives you a reading of how much current that passes through in amps, that tells you about the column of charge that pass a point in a circuit in a second. So you have been given an equation, and you can substitute that from the formula or from that the units for each one of those quantity that you are measuring. Now, looking at those, especially current will be in a circuit flowing in the opposite direction to the electrons. So those are some of the concepts that we have studied in our past two lessons on electricity. Now, in our next lesson, we'll be going through and then looking at charge and also the voltage. Right, let me give you an example of one of these. For example, if a charge has to pass through, it must have some kind of energy to do that. And especially when it is flowing in a plant, let's say for example a bulb or globe, or even a resistor, some of these must become hot. Okay, heat is a form of energy that is given off. And also light. When this bulb is lighting up, okay, that shows you an energy that is given off. So what causes it to go through that? A voltage is simply a force that will drive that the charges or the electrons through the circuit. So that is what we'll be studying in our next lesson. You will be coming up with equations which are, okay, charge equals to energy equals to Q times V. Okay, so if this one gives you, let's say V, if the voltmeter has to give you the voltage, that shows you that the amount of energy that is given to 1 coulomb of charge. So in here you have V, which is equals to, okay, E over Q. And if you have to change that, it will be V equals to, or 1V equals to, okay, what is the unit for this energy? Right, joules, very good. So you'll have joules, this one will be coulombs, okay, -1 or something like that. So that is what we'll be going through in our next lesson. So with that, okay, that is the end of our lesson on electric charge and also the current. Okay, our keyword for today will be charge and current. Once again, good morning, pilot teachers and students. Good morning, class. Good morning, Mr. Sarama. All right, thank you very much. Amazing.